The United States has maintained an airborne nuclear command and control capability for decades, dating back to the early stages of the Cold War, when the need for a survivable, reliable method to direct nuclear forces became apparent. During that period, strategic planners recognized that fixed command centers were vulnerable to surprise attacks, especially under the threat of intercontinental ballistic missiles. The development of airborne command posts was driven by the principle of continuity of command, ensuring that the national leadership could issue orders to the entire nuclear triad, land-based missiles, submarine-based missiles, and strategic bombers, even if ground-based facilities were incapacitated. This principle remains central to U.S. strategic doctrine and underpins all modern planning for nuclear command and control. Historically, the Air Force operated the EC-135 Looking Glass aircraft, a highly modified version of the KC-135 Stratotanker, beginning in the 1960s. These aircraft were designed to be airborne continuously, 24 hours a day, as a visible and practical demonstration of deterrence. The Looking Glass fleet was equipped with secure, hardened communications systems capable of directly issuing launch orders to Minuteman missile silos, coordinating with bomber units, and linking with other strategic assets. The aircraft systems were designed to survive extreme conditions, including the electromagnetic pulse effects of nuclear detonations, which could disable unshielded electronics. The constant airborne presence of these aircraft during the Cold War era signaled to potential adversaries that the U.S. command structure could not be neutralized by a first strike, thereby reinforcing deterrence. The EC-135 mission eventually evolved with the introduction of the E-4B National Airborne Operations Center, based on the Boeing 747 platform. The E-4B is substantially larger than the EC-135, providing extensive space for multiple crews, communication systems, workstations, and redundancies. It is designed to operate for extended periods at high altitude and long range, using aerial refueling to maintain continuous airborne operations if necessary. Its survivability is enhanced through structural hardening, advanced communication encryption, multiple redundant systems, and defensive countermeasures, ensuring that it can function even in heavily contested environments. The E-4B serves as the ultimate airborne command post, capable of coordinating not only nuclear forces but also broader military operations, providing a flexible and resilient command capability in crises. Complementing the Air Force's airborne command post is the Navy's E-6B Mercury Fleet, which carries out the TACAMO mission, an acronym for Take Charge and Move Out. The primary purpose of the E-6B is to maintain secure, survivable communications with the U.S. ballistic missile submarine fleet. Submarines provide a hidden and highly survivable leg of the nuclear triad, and continuous communication with them is essential for ensuring a credible second strike capability. The E-6B can relay emergency action messages and even directly transmit launch orders to both sea-based and land-based strategic systems if required. In addition, the E-6B serves as a secondary airborne command post, ensuring redundancy in command and control in case the primary E-4B or ground-based networks are compromised. However, both the E-4B and E-6B fleets are aging. The E-4B is built on a 1970s airframe, while the E-6B is derived from the Boeing 707, a design originating in the 1950s. Aging airframes create operational and maintenance challenges, including higher costs, longer downtime for repairs, and potential limits on mission readiness. Modernizing these capabilities is therefore a critical priority, balancing operational requirements, cost efficiency, and technological advancement. The Navy has initiated development of the E-130J as a replacement for the TACAMO mission. The E-130J is based on the C-130J-30 transport aircraft, a modern, widely used platform known for reliability, modularity, and operational flexibility. The C-130J-30 variant features an extended fuselage, providing additional space for operator stations, communications equipment, redundant systems, and other mission-specific modules. By leveraging a widely used airframe, the Navy can reduce acquisition and maintenance costs, increase fleet size without extreme budget pressure, and maintain a highly flexible operational posture. The E-130J will integrate advanced communications systems capable of connecting with ballistic missile submarines, land-based ICBM forces, and other command nodes, maintaining continuous and secure channels even in highly contested or degraded environments. The modernization effort is focused on ensuring redundancy and survivability. Whereas a single large aircraft like the E-4B represents a high-value but finite asset, multiple E-130Js, operating in rotation or simultaneously can provide continuous coverage with less risk of total mission loss. These aircraft can operate from dispersed airfields, fly long-duration missions, and remain in communication with both submerged submarines and land-based strategic assets. The modular nature of the C-130J airframe allows future upgrades to be incorporated without replacing the entire fleet, extending service life and maintaining technological superiority. Strategically, the move toward a diversified, modular fleet enhances deterrence. Multiple airborne command posts complicate any adversary's targeting calculations, as they cannot be certain which aircraft will be aloft at any given time, or where they will be operating from. This reduces the risk that a first strike could disrupt U.S. command and control. By maintaining secure communication links with every leg of the nuclear triad, airborne command posts ensure that a credible second strike capability is always available. Operationally, the crews of these aircraft are highly trained, capable of managing complex communications networks, issuing nuclear orders under strict protocols, and maintaining mission effectiveness under extreme stress. Flight crews, communications officers, and mission specialists operate in overlapping shifts to ensure continuous vigilance. The aircraft themselves are equipped with hardened electronics, redundant navigation systems, secure data links, and encrypted communication channels that connect with both terrestrial and satellite-based networks. These systems are designed to survive electronic warfare attacks, cyber intrusions, and even the direct effects of nuclear detonations, ensuring that command and control can persist under the most severe conditions. Long-term projections envision a layered, resilient airborne command architecture. The E-4B will continue as the most survivable, high-capacity airborne command post, capable of coordinating broad military operations at the national level. The E-130J fleet will provide operational flexibility, redundancy, and tactical coverage for TACAMO and possibly limited Air Force command post roles. This layered approach ensures that airborne command capability is robust, cost-effective, and capable of adapting to evolving threats. From a technical standpoint, the integration of multiple E-130Js allows for continuous rotation cycles, ensuring that at least one or more aircraft are always airborne while others undergo maintenance or repositioning. Their modular design enables upgrades in communications technology, cryptographic systems, and operator consoles without extensive downtime. The fleet can support both day-to-day command and crisis operations, providing rapid scalability for global contingencies. The U.S. approach emphasizes practical, measurable outcomes, survivability, continuity of command, secure communication, and operational flexibility. It is designed to ensure that under no conceivable scenario is U.S. command and control compromised, reinforcing deterrence and signaling to potential adversaries that any attack would fail to eliminate the nation's ability to respond. By combining modern airframes, redundant systems, and highly trained personnel, the United States maintains a credible, resilient airborne command network capable of sustaining national leadership and strategic operations indefinitely. This modernization also reflects a broader strategic philosophy. Dispersal, redundancy, and modularity are more effective than reliance on a single, centralized system. By integrating multiple platforms, the U.S. creates a command network that is harder to disrupt, easier to maintain, and capable of evolving over time. The combination of E-4B and E-130J aircraft, supported by secure communication networks and trained personnel, ensures that U.S. nuclear command and control will remain robust for decades, capable of adapting to future technological, operational, and strategic challenges.